Hello everyone and welcome to today's webinar for the Vale Pyrrhotite Resource Recovery Innovation Challenge powered by 9 Sigma. My name is Aya, I'm a marketing specialist at 9 Sigma and I will be your host today. Please note that this webinar is being recorded. The recording and transcription will be made available on the challenge page on 9 sites as well as on our YouTube channel. If you'd like to turn on the captions, you can do so by clicking on the More and 3 dots button on the screen and enable the captions. For today's agenda, I'll start by introducing the speakers, followed by an introduction about Vale Base Metals and a discussion on the challenge in greater depth, following with the process on submission. Then we'll take some time to address your questions during a live Q&A session moderated by my colleague Roha. You can also submit the questions anonymously by simply clicking on Anonymous Question. As a reminder, all participants are in listen mode only. As you proceed through today's presentation, please feel free to ask any questions at any time using the Q&A box at the bottom of your screen. We'll keep track of your questions and respond to them during the Q&A portion of the webinar. Should you need any information or assistance outside of today's webinar, please feel free to contact the 9 Sigma provider help desk at phd@9sigma.com. Please be introduced to my colleague Roha Ali Khan, the Technology Associate at 9 Sigma and the project lead for this grant challenge, who will be moderating the live Q&A session and explaining the submission process. Let's also give a warm welcome to our panelists, Adam Macmillan, the Director of Research and Innovation Vale Base Metals, Christian Spano, the Director of Circularity at Vale Base Metals, Inge Mihailov, the Technical Manager at Vale Base Metals, and Suzanne Balima, the Pyrrhotite Open Innovation Manager at Vale Base Metals. I will now give the lead to Adam, who will go ahead and explain a little bit about Vale Base Metals.
Thank you, Aya. Good morning, good afternoon, and good evening to everybody. Thank you for taking the time to join us today to learn a little bit more about the Vale Base Metals Pyrrhotite Open Innovation Challenges. Before we begin, I want to acknowledge the Indigenous lands where we are gathered today and where I'm speaking from. I am located in Treaty 13 territory of the Mississaugas of the Credit. This land has also been the traditional land of many First Nations for thousands of years, including the Anishinaabe, the Chippewa, the Haudenosaunee, the Wendat, and the Mississaugas of the Credit. It is now home to many diverse First Nations, Inuit, and Métis people. At Vale Base Metals, we are committed to working with Indigenous community partners on actions to support truth and reconciliation. I encourage all of us to think about ways that we can support truth and reconciliation through our work and in our personal lives. Next slide, please. I'd like to talk a little bit about Vale Base Metals and who we are and why this is important to us. So Vale Base Metals is a global mining company committed to safely delivering critical metals. We are a leader in the production of low-carbon nickel, copper, cobalt, platinum, group metals, and precious metals, all essential for the world energy transition. We have global operations in Brazil, Canada, Indonesia, Japan, and the UK, and we are committed to safety, sustainability, innovation to deliver these essential minerals while prioritizing the well-being of our planet and communities where we operate. And now I'd like to talk a little bit about the challenge overview. So this actually is really an opportunity for us. And the opportunity is that pyrrhotite tailings are produced around the world in Canada, Australia, Europe, and the US. And there is some estimates of over 100 million tons of this material, which contains significant quantities of nickel, sulfur, iron, copper, and other valuable elements. For those who may not be aware, nickel sulfide milling operations typically produce two types of tailings, a rock tailings, which can be used in civil construction material, and pyrrhotite tailings. Pyrrhotite has historically been processed as a primary driver with nickel, and this is done through two different processes in the past. Pyrometallurgically, with the nickel, iron, and sulfur recovered, although this has proven some challenging economically, and also hydrometallurgical routes have been examined with challenges existing in the sulfur and iron material management. We also believe that there's been a missed opportunity in terms of recovering some of the other critical minerals that are contained within pyrrhotite tailings in some locations, such as copper, cobalt, and the PGMs. And so for this, we present this opportunity of the Pyrrhotite Open Innovation Challenge. We're looking for folks who can complement our expertise, help us with beyond what we understand to learn from as part of our process. Sustainable processing, we believe in really minimizing our footprint and reducing, reusing, and all of the elements of circular economy in our processing. We're looking to maximize the value extraction in terms of all of the elements that are within pyrrhotite. And in the end, this needs to be sustainable from an economic processing standpoint to be able to provide a return to our stakeholders, communities, and shareholders. And with that, I'm going to turn it over to my colleague Inji, who's going to talk a little bit more about pyrrhotite and this opportunity.
Hey, thank you, Adam. Good morning, good afternoon, good evening, everyone. Let me outline in a few words the challenge, which we look at it as an opportunity around pyrrhotite. So the pyrrhotite tailings comprise mostly pyrrhotite mineral, and pyrrhotite is basically iron sulfide. Typical content anywhere between 44 to plus 80%. The nickel that historically has been the main value driver is finally disseminated inside the pyrrhotite, which means that to recover the nickel, we have to break the pyrrhotite. One big challenge is that the nickel level is fairly low, anywhere between 0.5, maybe 0.7%. Therefore, we need to process very significant quantities of this material to recover, economically significant quantities of nickel. In the past, as Adam mentioned, there have been two main approaches to dealing with pyrrhotite. One is pyrometallurgical, the other is hydrometallurgical. Our predecessor company, Inco, used to operate a plant in Sudbury called Iron Ore Recovery Plant, which was a combination of pyrometallurgical, roasting of pyrrhotite to make sulfur dioxide and then acid, then recover iron as hematite, and through a fairly complex back-end hydrometallurgical flow sheet to recover nickel in a form that then ultimately becomes nickel to the market. This plant, you can learn more about this plant in the references that we have provided, but the plant at the end was shut down as being uneconomical. There were other processes as well. The other major company in Sudbury operating at the time, Falconbridge, today this is under Glencore. They also had significant developments for pyrrhotite, but none of these really saw the light of day. In recent years, there has been a lot of work on hydrometallurgical processing, including bioleaching. And some of the main challenges of the hydrometallurgical processing is what to do with the iron. This pyrrhotite is iron sulfide, so a lot of iron, a lot of sulfur. Often the leaching will result in more residue being produced than what we start as pyrrhotite material. So there have been a number of challenges. Now, today, of course, we want to rethink the pyrrhotite tailings, and that's why we are coming up with this open innovation challenge. We want to look at sulfur as a valuable ingredient and how that can be recovered. We want to look at iron, how to recover the iron to something that is usable, and of course, how to recover nickel, copper, cobalt, and even some level of precious metals that pyrrhotite tailings do contain. So really, that's the challenge: is how do we come up with a process that can address the recovery of the constituents of the pyrrhotite tailings? Next slide, please. Okay, can we go to the next one? So for us, what would success look like? And in today's environment, we definitely would like the successful process to embrace the principles of the circular economy, which means we reuse, we recycle, we don't create new wastes. So in an ideal scenario, we want the pyrrhotite tailings from being stored today to basically to be converted into valuable products. We want all the components to be recovered to something important for society and can be used downstream. We also want the process to be economically viable, which often means, in terms of energy, in terms of CO2 footprint, has to meet these principles. And last but not least, the process has to be scalable. And what we mean by scalable is we have to treat very large quantities of pyrrhotite because the amount of, first of all, there's a lot of that material. The level of nickel is low. So typically say something like 3,000 tons of pyrrhotite per day, just to give you an idea of the scale of the operation that we'll be looking for. Okay. And with that, I will pass it on to my colleague Susan for further comments, presentations. Thank you.
Thanks, Angie. So what I wanted to talk about is depending on where you choose to focus in the solution that you propose, there are some important characteristics for you to keep in mind. So 6 are highlighted here. So if you're looking to propose something related to sulfur, it's worth noting that we're interested in solutions that would recover sulfur in a commercially viable way, such that it can be co-located and that we can use that sulfur in a different process. If you're focusing on iron and nickel recovery, we'd be interested in processes that achieve efficient nickel recovery as well as efficient iron management. Remediation-wise, we require that all the solutions improve environmental sustainability, as well as the tailing residue that it remains has strong environmental stability. We also obviously value the environmental impact of the solution. And so any solution that reduces energy consumption or reduces CO2 emissions in the process of recovering those materials is definitely something important to look at and consider. Efficient recovery, again, we are working with different kinds of byproduct, and being able to efficiently recover them is of primary importance. And finally, in terms of waste to energy, we're also interested in concepts that are not necessarily just focusing on the recovery of the materials, but a concept like waste to energy, where the energy generated from processing tailings could be reused to contribute to the overall energy needs, is something that would also be of interest. Aside from that, if you have any proposals that tackle anything that's not listed here, but do still meet the success criteria that Angie mentioned earlier, those are also of interest. Next slide, please. What we would not be valuing or interested in terms of solutions that are being proposed is a solution that produces more residue than the current volume of pyrrhotite tailings, a solution that produces CO2 emissions or relies on sources of energy that are generate high CO2 emissions, or any solution that has, generally speaking, a negative impact on the environment. That could be the energy source, but also the reagents or any effluents that are produced. And finally, any solution that replicates previously known solutions, so the known hydrometallurgical or pyrometallurgical routes that in the past have been proven uneconomical, are things we wouldn't be interested in. The caveat there, though, is that if you are able to provide additional sustainable or environmental benefits to those known routes, that would be something that we'd be open to looking further into. Just to highlight that on the challenge website, we did list some papers, some scientific papers that highlight what those previously known solutions are. So if that's something that you're not familiar with, I encourage you to go take a look to get an idea of what that is. And I will pass it back to you, Aya.
Thank you, Suzanne, Adam, and Inji. Now we'll go ahead with Roha, who will explain to you how to submit your proposal. Roha, up to you.
Thank you, Aya. Hello, everybody. My name is Roha. I am the project lead for the Vale Base Metals Pyrrhotite Resource Recovery Innovation Challenge, and I will be walking you through this proposal submission process. So first of all, please visit the challenge website. The link to that is www.9sigma.com/s/Vale Pyrrhotite Innovation, or you can flash the QR code that you see on this slide and in the next ones. On the website, you'll find information about the background, the challenge prizes, and the opportunity to potentially collaborate with Vale to help develop the selected scientific proposals. On the challenge tab of the webpage, you'll find information about the topic, the technical criteria, and the types of proposals that Vale is interested in. And this is really important because this will define the type of proposals that are really going to excite the evaluators and help accentuate your organization or your company for Vale. Additionally, in the resources and FAQ section, you will find attachments that will give you more details as well as a summary of the challenge itself. Next slide, please. So when you're ready to start writing your proposal, please click on the Respond button that you will find at the bottom of the Home tab. If you've got a 9sides account already, you'll be asked to log in at this point. And if you don't have a 9sides account, you'll be asked to create one. That's very easy to do. You just enter your email, create a password, and this will help us ensure that we can contact you again about your proposal in case Vale is interested or they have any follow-up questions. Next slide, please. So once you've done that, you'll see the response form, and you can see a preview of that on the right-hand side of the slide here. It's essentially just a series of boxes where you will type in your response, or you can copy and paste it from another document. There's also a space for you to upload any attachments there, and that could be additional images, diagrams, publications, or even your CV. Some people prefer to write their whole response in a Word document or a PDF document with their answers to all of the sections and upload it as an attachment. And you're very welcome to do that if that's easier for you. You can save your response at any time on our website and come back to edit it later. So what should you include in your proposal? Well, the first thing for you to note is that you must not share any confidential information at this point. There's no need to disclose your special know-how or your proprietary knowledge. You can tell us what you can achieve, what types of outcome you can deliver, but we don't need you to tell us exactly how you do it if you don't want to. Secondly, Vale is very interested to understand the approach you will take. So what's unique about your approach? What's different? How could you work with Vale to further develop and scale up your technology? And you'll see in the response form, there are sections for each of these things, and you're specifically asked to describe this. So please do include this information. Vale would also like to know about you. So your past achievements, details about your team, your capabilities. And once you've completed the response form, you just need to check a box to show that you've agreed to the terms and conditions and that you consent to them. And when you're ready, you simply click on the submit button. The response will then be automatically saved in our database. So please note that the deadline for submissions is the 31st of May at 5 p.m. Canadian Eastern Daylight Time. And that's all I wanted to say about submitting an entry. Now, let me share some more details about the selection process itself. So the evaluation of the proposals and the determination of the award will be made by a team of evaluators composed of Vale Base Metals experts as well as external professionals. From Vale, Adam McMillan, Inji Mihailov, Manchu Shu, and Suzanne Palima will be the evaluators. Besides the Vale experts team, 2 other external members will also be joining the evaluation panel. This will be Edgar Peak, who is the Director of Technology and Strategic Development within the Rare Metals Division at Neo Performance Materials, and Tony Filmer, who is a distinguished metallurgist who earned his PhD in chemistry and is now at Rio Tinto. You'll be able to find all the details and the bios of each one of our evaluators on the challenge webpage in the Evaluators tab. So the selection process itself will be comprised of 2 phases. In the first phase, phase 1, entries will be evaluated and shortlisted based on the submitted written proposals. And then the shortlisted respondents will then be invited to join phase 2, where they will have the opportunity to present the solution to the evaluators in an online pitch session. And after phase 2, the evaluators will select up to 3 innovation laureates teams to be awarded the final prize. Great. Okay. So I noticed that some of you are interested in asking questions and you're raising hands. So I will now be moderating the much awaited Q&A session. As you can see, we have a great panel of experts with us today, and I will be directing your questions, the ones that we've received in the registration and the ones that we've received in the live session today, to the relevant panel member. Other panel members are also very welcome to participate in the discussion. We will try to address as many questions as possible. So, without any further ado, I would like to direct the first question to Inji. So Inji, you talked about it a bit before, but if you could just provide any details of results or articles describing failed or incomplete attempts for this challenge at Vale.
Okay, all right. Thank you, Raham. I think believe Suzanne mentioned, we have provided a list. It's a it's not full list, but a list of selected references that are publicly available on prior work that has been done. And specifically, I would like to mention the excellent review article by Edgar Peak. He's one of our evaluators in the team from the time he was working for Falconbridge in Sudbury on the various routes for pyrrhotite processing, as well as an article by Bruce Connard, who recently passed away. He was a very distinguished professional with our company. And really the challenge with the processing has to do with the fact that there's just a lot of iron, there's a lot of sulfur, and just a little bit of nickel. It is difficult pyrometallurgically to make iron oxide that is free of nickel, that can feed into say stainless steel for steel production, and then recover the nickel in a form that can, something that can be recovered and coming to final product. The iron chemistry pyrometallurgically is complex. There is hematite, there is a magnetite. Nickel gets lost in some of the magnetite. So it is quite challenging and quite expensive as well. Hydrometallurgically, the sulfuric acid leaching system, there have been various studies of if you do a total oxidation of the sulfide sulfur to sulfate, this generates acid. This acid needs to be neutralized. There is significant iron dissolution. Often, we end up with a lot more residue than you start with. If the process is stopped to elemental sulfur, then the challenge is how to recover the elemental sulfur. So there isn't at the moment a well-established, proven, viable technological solution that is also economical. And that is the challenge, really. Okay.
Thank you. Thank you for that, Inji. The next question is for Suzanne. Suzanne, could you give details about the deadline, main aims, and how to structure a team for this challenge?
Sure thing. So in terms of deadlines, the big coming one really is May 31st, which is the deadline at which we will stop receiving submissions. However, between now and then, there's still an opportunity if you have any further questions to reach out to the 9 Sigma team. There is a contact information, which I believe is you, Roha, on the website. So if, as you're working through it prior to May, you have any questions or want to clarify anything, please feel free to reach out. In terms of structuring the team, I would say that would be really subject to or dependent on the kind of proposals that you have. But some things to keep into consideration are this is the team that would, if successful, implement the solution or the next step. So thinking about the capabilities of the team, the size of the team would be important. Because it's still R&D, so we don't expect that it would be a very big team, but those are considerations to keep in mind when you're thinking about how to propose. And I would also say if you see any gaps in your team's capabilities, to just highlight that it's not a negative. It's good for us to be aware that you do see gaps in the team that you currently have formed.
Great, thank you. Thank you, Suzanne. The next question is for Christian. So we see that you've talked about circular economy principles. What are these circular economy principles, and which one of these principles has the highest priority for Vale in this challenge?
Thank you so much for the opportunity, Roha. I think we need to focus on the principles that would apply to the mining and metals industry. And I would say that the first one is that we need to focus on resources. We need to go away from the, let's say, traditional view in the plastic space or the food space that prioritizes a view on waste and how to eliminate waste only. And I say this because what we are trying to find with this challenge is a way of identifying and recovering a number of metals and resources from tailings. And so there is a lot of value and wealth that we are after, and trying to apply a lens of waste only will take us only into mitigation or some sort of strategy that doesn't take us to where we want to be, which is a value view. The second principle, I think, is that this links with a number of other areas that are crucial not only for mining but for humanity. So, and you presented already in some of the points before, applying this circular approach to a new resource at site in the form of tailings today really can bring us closer to nature positive results, to a just transition, and closer to a net zero emissions trajectory. So it's a very strong lever that can deliver, multiple outcomes with one shot. And the third one, just for now, I mean, that we could be speaking about this for hours, but the third one, I think, is that we need to, and this has already been covered by Ingi and to some degree by the rest of the team, but it's very important to see this as a scalable opportunity. This, in our view, these circular opportunities can really transform the industry, transform the regions where we operate. And it's crucial then that if we treat this as a resource, as a real opportunity, then scaling them fast, safely, and at speed could really help us to tap into value for everyone involved, for all stakeholders involved. So how do we see this engagement with all of you as a way of unlocking transformational value is something crucial and important. I'll leave it there for now, Rojo, if that's okay.
Yeah, that's very helpful. Thank you, Christian. The next question is for Adam. So Adam, what are the procedures and likelihood for future joint collaboration in case the proposal is awarded?
Great, thanks, Roha, and thanks for the question. I think, as Christian just alluded to, what we're really looking for here is ideas that are scalable. And so when we think about what we would be expecting from a submission, It's concepts, it's ideas, it's proposals that we could then engage in a discussion in terms of further development. We would be looking to work with you, the laureates that are successful through this Open Innovation Challenge, such that different avenues could be pursued, but definitely we view this as a first step into how we would develop a solution.
That's great. Thank you. Thank you, Adam. The next question is for Inji. So Inji, at which maturity level are the results of research expected? Can we apply without being tested for the minimum criteria? And also, what information should be provided in a feasibility plan for lower maturity solutions?
Yeah, great question. Thank you, Rohan. I think it's a bit like what Susan explained. We are looking, first of all proposals are welcomed. That has to be made very clear. We're looking for new concepts, new ideas. So we're looking for the ideas for people. Even though this idea may not be fully implementable as a solution, we would love to see what is the thinking behind. How is it the proponent, how is the submitter thinking of how this idea could be turned into meeting the objectives as we have outlined? Even though they don't have a solid proof of this, that's okay. But we will be looking to understand how this idea could be implemented and meet the overall ultimate criteria of the project. So yes, it could be a very low tier level, that's all right. But again, what we're looking for is the rationale, the thinking, this element of creativity in what is being proposed, that we can clearly see how this could become reality. Okay, I'll give you an example. Sometimes we talk about elemental sulfur. So sulfur is a major component of these tailings. It's iron and sulfur. So I often like to say that pyrrhotite is about iron and sulfur, not so much about nickel, but nickel is important, of course. Now, if we say, okay, we'll stop the sulfur transformation to elemental sulfur, fantastic. But how? What is your idea of recovering this elemental sulfur? We will be looking for, is this idea practical? Could that be achieved with reasonable economic means? So that's what we're looking for, these nuggets of thinking that we can link to something that is eventually practical, even though the submitter may not quite fully have that. Okay? That kind of, this is what I think is the answer. Thank you.
Yep, that's very helpful. Thank you, Inji. The next question is for you, Suzanne. Somebody has asked, after the selection of the laureates, what is the anticipated timeline to develop the proposed ideas?
This again will be highly dependent on the solution that is proposed. We at this point expect anything from a concept to something, a technology that is, high TRL. And so understandably, the approach and the next steps for a solution on the very low maturity side and the very high maturity side would look different. That's one piece. But also based on what you just heard from Inji is that the proposals we expect should have an element of creativity, which means they should be unique in one way or another. And so I think the next steps will be very customized, depending on what you offer. I believe in the response form, there is a section requesting for how you envision the next steps to be. And I think this will have to be a conversation between, you, the team / the person submitting and Vale to understand, what support is required, how long could that take? And then I think from there we'll decide together. So it's hard to give maybe a very crisp answer, but I want to put out there that it will be a collaborative effort. So it won't be a timeline that we push on you. It will really be a discussion between both parties.
Yes, absolutely. Makes sense. Thank you, Suzanne. The next question is for you, Adam. Somebody has asked, what is the main priority between generating value by recovering metals and generating other commodities?
Great. So I think, maybe kind of circle back to what some of my other panelists talked about. I mean, really at the end of the day, we look at ourselves as a natural resource company. And so, while our primary commodities today are nickel, copper, and cobalt, we recognize, that there are many elements within this. And for us to sustainably and successfully process these tailings in a way that encapsulates the circular economy principles that Christian outlined, we really have to take a step back and say, what is the value that we can extract from there? And so, Inji highlighted a little bit about, the sulfur and iron challenges within this product. We have a long history of nickel processing. So I would say that, when you're looking at some of your submissions in that, if you're weaker in, say, some of the nickel processing or unsure, that's probably something that we're more comfortable with than if it's very strong in, say, a nickel, but some of the other areas are not as clear, simply because, that's not. So that's why we're doing this challenge, is to find new and innovative ways to do this. So I think rather than focus on a single commodity, really start to encapsulate to say, what is the value in those tailings, in the pyrrhotite? And then what is the product that you're putting out? And product not just from a metallic nickel or sulfur, elemental sulfur, whatever that is, but also the residues that you're doing. We highlighted that we don't want to generate more residues than we currently have, but we're also going to be looking at what is the actual residue you're generating, not just the volume, but what type, because ultimately we want to go to a zero waste type process. And so does this help us get there? Or is this, we're recovering some of the elements, but we're actually creating maybe new challenges that we don't want to tackle. So I think that's an important point when you're looking at your submissions, in that you're encapsulating really a complete thought process, not necessarily solutions, but at least you've thought it out. That's really what I think is critical in these submissions.
Thank you, Adam. The next question is for you, Christian. What are the lenses that you are going to apply to rank the proposals? Are these going to be purely technical?
I think the short answer is no. Let's say that what we are looking through this Open Innovation Challenge is new thinking, and there's a strong element of technical thinking, of course, But when we think about the outcomes, this has to do with value in terms of what kind of materials and resources can you extract, to the point that Adam has just made. Again, what is it that comes out? What is the scalability? For me, a key point is, when we think about scalability, there is a point where we can do great things at niche level, and it's great because we have found something new, but not great because it's small, doesn't change much things. There is the next phase where you can do things at scale, but an economical level. And then you reach scale at economic level. And the final point is, what can we get to solutions that can really transform Vale Base Metals and ultimately the industry, no?
Yeah.
And so when we think about that, there is obviously an element of technical knowledge, that we have appetite for. But when we think about the outcomes of that, there's an element that goes beyond.
Yeah, that makes sense. Thank you, Christian. The next question is actually for the 9 Sigma team. So somebody has asked us, will we be notified on how we ranked in this challenge? I can answer this question for you. So like we mentioned, by the end of September, Vale will decide which teams they want to award the innovation prize. And at that point, we will notify not only the winners, but also everybody else of the outcome of the challenge. So we will make sure that you are updated throughout the evaluation phase. And if you have any questions, like we mentioned, you can always reach out to me. We will be sharing our contact details by the end of the webinar. The next question is for Inji. So Inji, somebody has asked us, Is there existing infrastructure on site that could be leveraged to help process specific forms of recovered metals? Are certain forms of recovered metals more desirable over other forms? For example, nickel sulfide versus metallic nickel?
Thank you, Roham. Okay, so the short answer to the first question, whether it's existing infrastructure, is yes. We are looking for tailings, pyrrhotite tailings in the Sudbury area. This is a world-known area of mining for more than 100 years. Two major companies, Vale Base Metals and Glencore. So there is a lot of infrastructure, a lot of local knowledge and experience. So yes, absolutely. On the second question on preferred forms of nickel, I would say at this point there is no preferred form, as long as it's a form that is processable and can be ultimately of interest to the market. Okay, so whether it's a hydroxide or a sulfide or an oxide, it doesn't matter really at this point. Okay.
So Roha, can I just maybe add something to complement Inji? I think, you know, one thing that when you're developing your proposals is really, you know, and it comes back to, I think, some of the circular economy principles, but really the complete solution in the sense of if you have an intermediate product, that's fine. But how are you going to handle that intermediate product, right? So an intermediate nickel product is handled very different than, say, an intermediate potentially sulfur product. And so think about that in terms of if you require other infrastructure and things like that. You know, again, that will sort of determine it, right? If you've got an intermediate product that requires a lot of specialized handling, things of that nature, that is probably more challenging than one that is much easier to handle. So, you know, solids versus liquids versus gases, things of that nature. So definitely, you know, really consider sort of the outputs of your process, of your concept, in that, you know, it doesn't have to be complete, but at least you considered it and understand what would be required post that if you're going to be looking for something, you know, complementary that is existing at site.
Great. Thank you. Thank you, Adam and Inji, for that. The next question is for you, actually, Adam. Somebody has asked us, can we work from a group where individual members have a different nationality?
So, you know, short answer, yes. You know, I think really we're looking to find new partners for collaboration here. You know, it's one of the kind of the principles behind Open Innovation Challenges anywhere. And so, you know, we're open to the idea of if you're not located in the same place, that's fine.
Great, thank you. The next one is for you, Christian. How does this challenge contribute to Vale's sustainability ambitions?
How this? Can you repeat the question, please? You block a little bit.
Of course. How does this challenge contribute to Vale's sustainability ambitions?
Perfect. Thank you. Look, I mean, circularity is a mechanism. No, it's not a goal in itself. It's a way. It's a strategy. It's a set of strategies. And when we think about what we have been saying, if we start to frame tailings and general, you know, everything that happens outside that is not a natural resource as additional resources, and we manage to apply thinking, technology, and partnerships so that we can get, we can trap carbon, we can recover more material, we can become net zero, we can become net zero waste. And by doing that, because everything happens at the site level, offering more jobs, better access to opportunity. It's as simple as saying that these kind of circular approaches are central and not cosmetic to deliver into any sustainability outcome we want to deliver. There's an interesting piece that has been recently launched by the United Nations International Resource Panel, the Global Resource Outlook Report, that provides extensive data on how circularity is absolutely crucial to deliver to net zero, nature positive, and a just transition.
Great, thank you, Christian. The next question is a technical one, so this is for you, NG. What kind of pre-treatments were carried out on this material, like flotation, gravity, smelting, etc.?
Yeah, okay. All right. Thank you, Rohan. All right. So, okay. So perhaps this is something that we were not very clear. So it's a very good question. So the pyrrhotite tailings, they are a product from the mineral beneficiation of the ore. So we will have the ore, which is a sulfide ore that contains the value metals, a number of different sulfide minerals, and it goes through a mill, a flotation mineral processing facility, where the ore is ground, and then through flotation is separated into different fractions. We produce concentrate, which contains the valuable metals such as nickel, copper, cobalt, precious metals, and so on. Then we have rock tails, which are mostly silicates, as I think Adam mentioned very early in this presentation. The rock tails are used for road construction, backfill, those sorts of things. And the other component is the pyrrhotite tailings. So the short answer is that they are coming from the mineral processing of the ore. So they will be relatively small particle size because it's fairly reasonably finely ground, and we can provide the data on that. And that's what it is. It's essentially a product from mineral processing. So it will have a bit of some flotation chemicals perhaps still remaining, that sort of thing. Okay.
Thank you for that, NG. That makes it clear. Thank you. So the next question is for you, Suzanne. When responding to the call, do we have to offer a complete solution?
No, we understand that it is a very complex and big problem to solve, which is why it became an open innovation in the first place. And so given that complexity, I think we would be okay with solutions that address part of the different elements of the opportunity. So the slide that Inji was speaking to, and some of the things like, if you have a solution that just focuses on the sulfur recovery, that would be a good proposal to share, even if you're not looking at the nickel or the iron side. And similarly, if you have a solution that focuses on iron, but not on nickel or sulfur, that would be okay too. If you have a solution that focuses on energy, that's okay. I think part of the work on the Vale side would be for us to piece that puzzle together. And so absolutely, if you have one specific area that you think you can contribute to, I do encourage you to submit the proposal for that.
Great, thank you, Suzanne. The next question is once again for you, NG. How do we get more information about the beneficiation process? What are the physical characteristics of the tailings, PSD, specific density? And I see that a number of people have asked about.
I lost you a little bit at the end, Rohan, but I think I got the main point of the question. I think we given the interest, we can prepare a description, a little bit more detailed description of the process of how the pyrrhotite tailings are produced, the composition, the particle size, and other physical properties of the tailings, and we can make it available through 9 Sigma.
Great, thank you, NG. Can you hear me okay now?
I can hear you, yes, yeah.
Okay, great. The next question is for you, Adam. Are the tailings in a solid form, or are they liquid, slurry in nature?
Yeah, so typically when we process tailings, they do come into a slurry form. But I think for this challenge, one of the things we've excluded from that is whether they would be tailings that are produced at the moment or we're recovering from the tailings area. And again, it comes back to Suzanne's point on the complexity, sort of the size of this challenge, this opportunity. And so what we want to do is focus on the actual processing. So if your process assumes that these are in some form of dried form, that's okay. If you assume that they're in a wet form, and that's fine too as well. I would say just state that assumption up front so that it's clear to us. We're not going to specify whether it would be in sort of a dry solid form or in slurry.
Great, thank you. The next question is for you, Suzanne. I'm already a part of a project in which we are collaborating with one of Vale's departments. Can I still participate in this challenge?
Yes, you can. So the challenge is still open to anyone. I will call out, though, the caveat is that if you are already working with Vale, if you've read the terms and conditions, you likely will not be eligible for the prize. Understanding that we want to make this a fair process for the 3 laureates that we do end up selecting. And so if you're already working with us, there may be some information you have access to that others, don't. So I would still encourage you to apply if it is a great proposal. We'll see how we manage that. But upfront, I do want to mention that you wouldn't be eligible for the prize.
Great. Thank you, Suzanne. Thanks for clarifying that. Next question, once again for you, Inji. How much material is expected to be processed per day?
Okay, short answer is around 3,000 tons dry basis per day. And it could be more, it could be less, but it needs to be a large quantity. The amount of pyrrhotite tailings that have accumulated over the years is huge. And there is various articles in public domain, in the press, in the media. People talk about billions of dollars of contained value. So the amount of the resources is huge. So therefore, we're looking at not as a small amount. It has to be, as I said, in the thousands of tons of pyrrhotite per day processing. So that's why we talked about scalable. It has to be scalable. It has to be big. Okay.
Great. Thank you, Inji. The next one is for you, Adam. Is removal of the tailing material from the dam part of the challenge?
Hi, Roja. No, thanks. I think just to reiterate that, no, it is not. So we've sort of put a box around this challenge to say that we will assume that the tailings, the pyrrhotite is available for you in the form that you require it for your process. So again, whether that's in a slurry or in a dry form. Back to Inji's point, that we're looking for something that's scalable on that 3,000 dry tons. But if you require it in a slurry form, that's fine too. But your challenge is not whether to recover tailings, the pyrrhotite from the mill as it's being processed and generated, or recovery from the tailings area. That's excluded from this.
Great. Thank you, Adam. The next one is for Christian. Are you seeking opportunities to extend the life cycle of components?
Yeah, I mean, that's the whole, if we think about, these are stocks of materials that we want to use forever, no? I mean, the beauty of everything that, the difference again between materials that are either burned or used and become waste immediately, they are consumables, or, the beauty of this is that what we're after is materials that are, that can last forever, can be used forever. They can build stocks that then are used forever. No, and so, but again, the way we should look at this is, of course, we want to extend the life, but more than extending the life, we want to start a cycle that allow us to transform the way we recover those materials. The way we have done today has created this opportunity in the form of very large tailings that are rich, but obviously. If we think about finding a solution like this, it would give us a massive opportunity to completely transform a landscape, completely transform an operation, completely transform the way we look at resources. And so the simple answer is yes, but I think this is around recognizing that we're recovering durable materials that we can use forever.
Sure. Yeah, thank you for that, Christian. So let's just do one more. So this is for you, Adam. Is the designated daily capacity of 3,000 tons per one site or on a global scale?
So we would be looking to scale this globally. So, you know, initially, if you've got it on one site, that's fine, but we would look to have this scalability to our other sites within our operations that have Pyrrhotite. So, you know, initially, you know, we're focused in primarily our Sudbury area, but it would definitely be on a global scale long term.
Great, thank you for that, Adam. So that brings us to the end of our Q&A. We will be posting answers to any of the unanswered questions along with the webinar script and the recording on the challenge page in the resources and FAQ section. We really value your active participation in the webinar, and we would like to thank everyone who has sent in questions. So a big thank you to you. I would also like to personally thank our esteemed speakers and panelists for providing such valuable insights and feedbacks in your answers. And now I would like to pass it to Aya to conclude the webinar.
Thank you, Roha. So now you have some final important information on your screen. You can visit our 9 sites websites. You can also scan the QR code to access it, to be able to visit the grant challenge, be able to register, download all required documents, and to submit your proposal. If during your submission you have any questions, please feel free to contact Roha on the shown email address, roha.khan@9sigma.com. And please keep in mind that the deadline is on May 31st at 5 p.m. Canadian Eastern Daylight Time, and no proposals will be accepted after this time. That concludes our webinar today. And as a final reminder, this webinar was recorded and will be made available along with the Q&A transcripts. And as a final thank you to Adam, Christian, Inja, and Suzanne for their time and expertise, as well as the team working behind. And a big thank you as well to our audience. We appreciate your time and look forward to receiving your submissions. And have a great day. Thank you.
Thank you, everybody.